Okay, just recording a quick tutorial there on a manufacturing systems type question. So we have a wee question here that would have been asked in previous exams. There's some worked examples here. So it asks for a few things here. So we're asked for the hourly production rate at the bottom to meet the demand is A, the hourly production rate to meet the demand, and then B, the number of workers and workstations required. So if we have a quick look here, where you can get some information on this is if we jump onto the Moodle page, and we have our formula sheet up at the top that I'll pull up in a second. But if we go back down to the very bottom to manufacturing systems, down towards the bottom, and it's this handout on integrated manufacturing systems, and there's a chapter of a book I referenced before, and in here you can read all about the manufacturing systems and about production lines and methods, etc. And if we go on down here, there's some examples here of cycle time analysis, and this is really what we're doing, and we're starting here with the various production weeks here. So we'll go through these formulas real quick here, and these formulas are supplied on the formula sheet. So if we just jump up to general here at the top, this is our formula sheet here, and if I just pull that in, just put in the formula sheet that you see it. So this is this year's formula sheet. It's the same that's on the exam paper. And this production and quality section here has the examples that we're looking for here: minimum integral, etc., production rate, workers, etc. All right. So you can have a look at that on the formula sheet. So this question here, I suppose, the first one we solve for is we look at our RP. Okay, and we look from the formula sheet there, there's our equation there for RP that we're going to use. And basically what that is equal to is basically our DA, which is our demand. Okay, so DA is 50,000 units, I think it is, yeah. So that's our 50,000, and that would be divided then, okay, by our 50. Okay, I just put that in a bracket here real quick. So it's 50 multiplied by our 6 shifts. Okay, so SW is shifts, and then the hours per the shift is 8. So it's 6 by 8. Okay, let's just zoom up there a wee bit on that. So it's 50 by 8. Okay, and if we calculate that out, then we basically get a rate, then our RP of 20.83 that works out on. Okay, so that's our required production rate. Okay, that's our RP. Then we move on to our line cycle time. Okay, and our line cycle time then, that has the formula again. You see it in the formula sheet. Paste that in. Okay, so a line cycle time is TC. Okay, and we can see it here what it is. So what we have is we have some efficiencies here. So we have to look at our line efficiencies. The line efficiency there is 0.95%, and the balance efficiency is 0.93. Okay, so we take the 95, it's the line efficiency here we're dealing with, and we basically, it's 60 multiplied by the line efficiency, which is 0.95, 95%, and it's divided then by our production rate. Okay, simple as that. So 20.83 that we got from that. So if we multiply them out and then divide it, we get 2.736. So you can keep maybe 2-3 decimal places, and this is no harm, just to keep the correct as such. And then from that, then we look at our service time. Okay, and the service time has a simple formula. Let's just paste it in here. Okay, and yeah, our service time there is basically, it's going to be equal to our 2.736 that we got our line cycle time, minus 0.1 or TR. Okay, and that is going to be equal to our 2.636. Okay, and then the time then we need to look at is the work, the amount of workers to operate line. All right. So if we looked at the amount of workers then to operate the line, it's basically W is the workers. We can see from the formula in the handout sheet. Okay, and that's simply then if we looked at that, it's the minimum integral, so it has to be the full number as such. So it's 60 divided by, and if we open our bracket, then we have our TS there that we're after getting, which is the TS is 2.636 multiplied by the balance efficiency, which is 0.94, I think it was 0.93 up here. See this balance efficiency up there, so it's 0.93, and that equals just get my calculator here again. So 2.636 multiplied by 0.93 equals to and divide that by so I'm just getting rounding that up, I'm getting about 25 workers. Okay, so I actually, sorry, I'll just do that again here. I actually used the wrong number. I used 0.94, so that'd be 2.636 multiplied by 0.93, so it'll be 60 divided by 2.45148, and that's equal to 60 divided by 2.45148, and I'm getting 24.47. So that has to be equal to, we can't have a half a worker or 0.4 of a worker, so that's equal to 25 workers. Okay, and that basically answers the question there. So this is only a short question, it wouldn't be a full question or anything like that. It might be worth 10 marks or something like that, but something like this was to come up. And again, the key thing is here that we get our production rate first, we get our cycle time then second, we're plugging them into the formulas, we get our service time, and we get the workers to operate the line. Okay, and it comes out rounding it up to full workers. So that's a brief tutorial questions there on the manufacturing rates and number of workers required for production.